Okay, so in lesson 1.4, we are going to be rewriting equations and formulas. And in particular, the way that this is going to be a little bit different than what we've done over the last several days is that at this point, our equations have multiple variables. So, as we add again, you keep hearing me say this layer after layer after layer. If we look back at, for example, what we did yesterday, things got pretty complex, right? And we had multiple steps and we had variables on both sides. And so things were starting to look pretty fun here. But even though there was multiple steps involved and variables on the left and variables on the right, if you look across, it was still just one variable, the letter F. Even if it was in multiple places, there was not different variables in the same equation. Same thing here. You look at yesterday's notes, it was X's, X's, X's. It wasn't X's and Y's or K's and R's, that kind of thing. So, we were able to, with simplifying, gather up and eventually get all of those X's in a single place, right? Today, we're going to be handling the types of equations that have more than one variable, okay? The most common time you see this is, for example, in formulas. The distance formula, is R times T, or, the formula for, all kinds of, science formulas, mathematical formulas. You have a couple of examples here. The formula for, converting temperature has Celsius and Fahrenheit in it. Simple interest has multiple variables, the principal, the rate, the time. So when you start to deal with formulas and other literal equations, which is what we call these guys, we want to be able to have the ability to manipulate and move things around, even if I have multiple variables. So let's kind of just formalize that definition. You just heard me say it, but a literal equation is an equation that has two or more variables. Anything with more than one variable. We can use inverse operations to solve for different variables and just reorganize it. So one of the big things I want to get at today is that for the most part, you're not going to be solving equations today as much as you are just reorganizing them or moving things around. So a lot of our answers are not going to be x equals 9 or y equals 7. It's going to just be the same original equation, just moving things around so that maybe instead of, the C being isolated, maybe we want the F by itself, right? I want an equation that instead of it giving me the temperature in Celsius, I want it to give me the temperature in Fahrenheit. So I would want to undo the stuff around the F, just like we have been with inverse operations, and reorganize this and rewrite it so that instead of it being written as C equals, it's written as F equals, right? So that's our goal today. And that's actually really helpful. I always think of science when I get to this lesson. We have a lot of formulas in science. And, when you're collecting data, the reality is that if you really have a solid experiment and are doing some sound experimental collection, you're collecting a lot of data samples. And so if you're plugging in something over and over and over again, you don't want to have to, for example, plug it in here, let's say you're solving for F. You don't want to plug in here and then have to undo all this to find the answer, and then plug in the next one and then do that all over again to find the answer, and then do the next one and do all of that. You want to rewrite the formula and get a new version of it for the variable you want, and then you can just solve, right? So this will make sense in a minute, a little bit more when we do it, but there's a lot of advantages to just being able to manipulate and move things. So long story short, my big ideas I want you to walk away with right now are that the steps we're going to do are nothing different. Okay, we're still looking at what's around the variable we want to isolate. We're still going to do the inverse operations. In fact, if anything, I think that these tend to be a little bit easier just because you don't actually have to do a lot of computation. You're just reorganizing and moving things, but you're not actually solving all the way, okay? So let me show you what I mean by that. Let's take a look at number 1, okay? So on number 1, first let's be really careful, especially now that we have multiple variables. Be really careful that you understand which one it is that you're trying to get alone, right? So the directions here tell me solve the literal equation for y. So this is really important, right? That way you're not doing a whole lot of work solving for x when, oh, I had to solve for y instead, right? So that way you know exactly where your target is, if you will. So first things first, identify where the variable you're trying to isolate is. There it is, okay? And then look on that side to see what was done that you need to undo, okay? So in this, in this problem, here's my y. And then what I'm noticing that happened here is that they multiplied by 5, added 8. I'm still going to undo those just like we did before. So I'll start off with what's not connected. We've done this before, doing the opposite sign. I'm going to get rid of the 8 first. That's a constant. So here, I want to line that up with the 2. Why would I do that? Well, because these are like terms. This is where I'm actually going to be able to combine. I wouldn't want to line it up with an x because I can't combine this 8, this is just a regular constant. I wouldn't be able to combine that with an x term. I want to line it up with a like term that I'm going to be able to do something with. So that cancels. And now on this side I have 5x. Negative 2 and negative 8 is negative 10. And then now I just have 5y. Okay. Next order of business is getting rid of the 5. That's multiplication. The opposite is division. So I divide by 5. But if I divide by 5 on one side, I have to divide the other side by 5. That means, and just like multiplication, division has to be distributed. So I need to make sure I divide everybody by 5. So just like multiplication, when it comes to multiplying and dividing, if there's more than one term and you have to do it to that side, right? I'm dividing this whole side by 5, then you have to distribute it and make sure that you do it to both. So 5 over 5, that cancels, and that just leaves me with x. Negative 10 divided by 5 is negative 2. And then, of course, on this side, the 5's canceled, and I got y. Okay, so I've reorganized and rewritten. Notice I don't have like an actual solution. I just have a different version of the same equation, but it's solved for the y variable, okay? And so not an actual answer, but just a reorganized version of the original equation. Let's try number 2. Identify where your variable is. That becomes most important today. We've been doing that, but this is when it really becomes handy because you're going to have multiple variables. Okay, I'm going to eliminate the stuff around. I'm going to get rid of the 7. That's a positive 7. Don't look behind. That negative belongs to the 4. It does not belong to the 7. So I'm looking at the sign in front. That's a positive 7. So I'm going to eliminate that with a negative 7. Like that. Okay, and that cancels. So on the left, I now have 3x minus 6, because positive 1 and negative 7 is a negative 6. And then I still have that negative 4y. Okay, and then the second step is to divide by the negative 4. So if I divide on one side by negative 4, I have to divide by the other side. But because I'm dividing the entire side, and there's more than one term, I need to be sure to distribute that and to make sure everybody has the opportunity to be divided. Okay? All right, so when we do that, 3 over negative 4, well, that doesn't divide evenly, and I'm okay with that because I love fractions. I'm going to leave it exactly like it is, no problem. And then over here, a negative divided by a negative becomes a positive, and 6 over 4, it doesn't go in evenly, but that can be reduced. I want you to see that and notice that and know that 6 over 4 does simplify to 3 over 2. And that's still now equal to just y because this canceled. Okay, so, and if I reorganize that with the y in front, y is equal to negative 3/4 x plus the 3 over 2, and that's the rewritten version of the formula, okay? Or the literal equation is what I should say. Okay, now, number 3 becomes really interesting. I want you to pay really close attention to this guy. It's going to help you with several others. But this actually introduces a concept that we're really formally going to go over much more in depth later on in the year. But it does come up here a little bit. So again, why is my goal? And a minute ago I told you identify where it is, identify where it is. Well, when I try to go identify, I realize hopefully pretty quickly, oh, wait a minute. I have 2 terms that have a y. And maybe I need to combine like terms, but then I'm like, oh, wait a minute, no. It's not a matter of just combining like terms. That is not a like term with that. This has an x, that does not. I can't actually, it's not a matter of just, oh, I haven't simplified, I need to combine them. No, these are really genuinely two different y terms that are not like terms. One's a y, one's an xy. And so I need to come up with a different technique because I'm not going to be able to get y by itself as long as I have it in two different places. So this brings up a really important concept that we call factoring. So just a quick review, okay? I want you to remember, and we've been doing this when we're simplifying, how I want you to remember how the distributive property works. So just as a side note up here, write this down. Remember, the distributive property says if I have something in front of the parentheses and I am multiplying that, you know, times more than one thing, I can group that to show it. And then in order to perform this multiplication, I would distribute the x. There it is. And x times y would just be xy. And x times 2 would be 2x, right? So if I had this original situation and I distributed, I would do x times y is xy, and then x times the positive 2 is a positive 2x. And that would be distributing the x term, and then I would have that x term in both of those, okay? What we're gonna do today to fix our little problem on number 3 is we're gonna do that distributive property in reverse, okay? So now I want you to look at this kind of, in reverse or backwards. Let's say we were starting off with this, okay? We began with this, and I wanted those x's to be in a single location. Well, I could do exactly the distributive property, but in the opposite direction. Because here's the bottom line, if I write this out. If we know by the distributive property that this right here is equal to this right here, then, guys, equality works in both directions. If it's equal, it's equal. If this is equal to that, then that is equal to this. Okay? It's not just a one direction type of thing. Equality means they are the same no matter which direction you're looking at it. So we've gone in this direction a whole bunch, but now we're going to go in this direction because what we want is to get that variable in a single location. So when you see that both of those terms have an x, what you're going to do is you're going to do what we call factoring. You're going to take both of those terms, divide that x out and put it out in front, and in parentheses you're going to leave the factors that are left over. So if I remove the x factor here, it leaves me with a y, and if I removed the x factor from there, it would leave me with just the 2. And a really good way to check if you did that correctly is that you should be able to distribute this back in at any point, and it should still be equivalent to the original. That's how you know that you've done this correctly. So that's what we're going to do right here. Okay, I have a y here and here, so I'm going to use this whole concept of factoring. I am going to divide that y and pull it out to the front, and in parentheses, I'm just going to leave the leftover factors. Well, in this first term, this is another place you have to be really careful with factoring. I had a y, and I want to divide it out, but what's y divided by y? It's a 1, and so it's super important. One of the most common mistakes that people make, or students make as they're learning this process, is that if the term is exactly what they're pulling, they think they don't have to write anything here. That is incorrect. You can also think of the fact that y is really 1y. So if that helps, go ahead and put that coefficient of 1 there. And remember that when you see a y, what that really means is you have one y factor. And when you pull that y factor, you still have 1 there. And I'll show you why that's so important in just a moment. Okay, so y divided by y is 1, so that's fine. And then in this term, if I pull that y, I'm going to have that negative 2x, okay? And this is why it's so important. The people that leave that off, let's say for a moment I forgot about that and I just write the negative 2x. If I multiply this by that, I don't get that entire statement. It's not equal to the original. I have to have a 1 here so that if I were to multiply this back in at any point, distribute it, y times 1 would be y, and I would still preserve that term. And then y times negative 2x would give me negative 2xy, okay? So these guys are equivalent. It's literally the distributive property in reverse, okay? Instead of multiplying it in, you're dividing it out and putting it out in front, okay? And it's equal to 15. But that solved our problem. Now we have y in a single location, one and only location right there. And then all I have to do to solve it or get it by itself is the inverse. So they're doing y times this group. The opposite of that is to divide by that group. And then I divide over here on both sides. And this cancels that because the opposite of multiplication is division. And so y here is equal to that 15, I should write it up here. Y is equal to 15 being divided by that negative, 1 minus 2x. So let me erase that one. Okay, and there's our answer. Not our answer, but our reorganized version, right? All right, let's check out number 4. Identify where your variable is. And let's chip away at the stuff around it and solve it, rewrite it. So I'm going to get rid of this term first. Since I'm moving the whole term, I'll just do the opposite sign. We talked about this last time, and I'm going to put this next to it. Since those are not like terms, it doesn't even make sense to put it underneath. Okay? But when you want to get rid of the entire term, you do the opposite sign. I'm not using division here because I'm not trying to keep x. You know, you only use division if you're trying to split these guys up. But I am not trying to do that. I'm just trying to get rid of the entire term on the left side there. Okay, so that leaves me with a negative y equals, and then I have these terms right here. So we're getting pretty close. And then I want you to notice we're not quite done. It looks like we should all be, so close to being done here, but that matters. It's not solved until it's a positive y. It's just y. I don't want negative y, I want just y. So usually the easiest way to do that is to divide through. Remember, that negative in front is the same thing as having a coefficient of -1, if that helps understand that. So to get rid of the negative, we're just going to divide by a -1. Knowing that a negative divided by a negative will cancel that and make it a positive. So now I have y here, -4 divided by -1 is +4, and a -3x divided by a -1 is a +3x. So just turned everything, basically changes all your signs. Guys, the short answer to that is if you end up with your variable by itself, except it's negative, as long as you change all the signs, you are okay. You have mathematically done no harm. Okay? Okay. Check out number 5. On number 5, we're solving for x. So there's our x right there. This kind of gets a little tricky when x is in the denominator. So we'll want to, it won't be isolated until we get it up to be at the top or as a whole number. We'll have to fix that in a moment. But first, let's isolate at least this term, right? So if they subtract the 12, this is usually where we start. So let's move that to the other side. This has 3 variables. Okay, and that's okay. It doesn't change anything about what I'm doing. I'm still doing the opposite or the inverse, starting with the addition or subtraction. There it is. Okay, that leaves me with x divided by y equals, and over here, I don't have a value of z, so I can't actually do that. I'm just going to write them next to each other. It's just z plus 12. And then here's the predicament. I can't do anything until, this is out of the denominator. So I'm actually going to, instead of dividing by y, I'm going to do the inverse of that, if nothing else, just to get y out of that denominator. So I'm going to multiply by y on this side, but that means I also have to multiply by y on this side. Okay? And it cancels, my y's are canceling here, but don't let that freak you out too much. We're doing x equals y on this side being multiplied by z plus 12, okay? And then, you might be tempted to distribute this, but actually because of what we're trying to do, you're better off not distributing, right? Remember what we did up here just a bit ago? We like it when that y is in one spot only. If I distribute it, it's going to look more like that up there. So if I distribute it, I'm going to get yz and y12, and I'm back to the same problem that I was trying to fix up here. So I actually really like that the y is just being, multiplied by this parentheses. I would highly recommend you don't distribute it because I'm about to just undo this and get that y by itself. I'm actually closer to the finish line and to finishing this problem by leaving it like this. So I'm going to divide both sides by what they're multiplying. So if it's y times that, then the inverse is just to divide by that. on both sides. Right? And that completely gets rid of that. And that leaves y alone, so y is equal to what I have on the other side, which is an x in the numerator and a z plus 12 down in the denominator. And I have reorganized it and rewritten it so that it is solved for y. Okay? One more practice on that, that distributive deal, right? This is another good example. There's my y there and there. This is all variables, and that's okay. But y is in more than one term, and I can't really combine those without, knowing what these are. So I am going to use that distributive property in reverse, which we call factoring. So if this has a y term and that is a y term, I can factor the y, and when I pull it, it leaves me with just the a plus, and then when I pull it from here, it leaves me with just the b. Okay, so that's that distributive property. And again, you could always mentally check this. You should be able to, at least in your head, distribute this back in and still get the original. So y times a is ya plus y times b is by. Yep, we're good. And now my y is in a single location, and I can divide both sides by what it's being multiplied by, which in this case is the a plus b. And that cancels that. So y is isolated, and it's equivalent or equal to k over that a plus b. There it is. Okay. Let's move on to the next page. I'm going to start taking it up a notch a little bit here. In this particular section, the goal variable, or the variable that we're solving for, changes, so be careful with that. We want to solve the literal equation for x this time, so just be on the lookout for that. Look at your literal equation, identify where your variable is at. In this case, it's all the way here on the end, and let's start moving stuff around. Okay, so if x is over here, I'm going to get rid of this term first, and I'll line it up with the one that's the like term. So I'll take away the 2r's. So I'll still have 4g, and then positive r and negative 2r is a negative r. And then on the other side, these cancel, but I still have that negative 2x. Step 2 is to get rid of the negative 2 that's in front of the x, because we want x completely by itself. So we'll divide both sides by negative 2. And when I divide on over here, since I'm dividing the whole side, I have to make sure I distribute that. It's going to look like that. Okay, this cancels, that gets x alone, and over here, 4 divided by negative 2 is a negative 2 with the g, and negative 1r, which if it helps, write it in, right? Negative 1r and negative 2, well, the double negative cancels, and 1 over 2 is just 1/2, so it just looks like that. So x is equal, you'll see that, okay, yeah. So x is equal to negative 2g plus that 1/2 r, or r over 2, however you want to think of it. R over 2 also works, just FYI. All right, next one. Notice where x is. That's really important. I got a z, here's x, and there's, all right, so I only have x in one place. That's kind of good news. Let's move the stuff around it, and then we'll divide by the 3. So first let's move the numbers around it. I've got to move that 12. So now I have 3z, and then positive 8 and negative 12 is a negative 4. That still leaves me with the 3x and then minus a z. So I still want to move this guy to the other side. I want that x by itself, so we'll add z on both sides. And again, notice I am lining it up with a like term. So 3z's plus another z is now 4z's with the negative 4. And on the other side, we've got 3x. And then last but not least, we'll get rid of the 3. We'll divide by 3 all the way across because we're dividing both sides. So x is equal to 4z over 3, which doesn't go in evenly, so I'm just going to leave it as a fraction. Okay, that's a terrible z. Let's try that again. Okay. And then negative 4/3 again. And I'm going to leave it as a fraction, and that is perfectly wonderful and less work and more exact. So there it is. Okay. And then these are practicing that distributive property. I want you to notice we're trying to get x alone, and there's an x here and an x there. So I'm going to practice what we talked about of factoring that x out, kind of doing the reverse of the distributive property. And if I factor the x out, I still have a factor of 3 in this first term, and I still have the 9 in the z. If you're uncomfortable or shaky about it, distribute this back in and make sure it equals the original. That's how you know you did it right. Okay? And now that we have rewritten this as a multiplication, instead of it being distributed in, it's factored out here and we're writing it as a multiplication, then we can just do the opposite of that, which is just to divide by that group. So if it's x times all of that, then I'm going to divide by all of that. And if I do it on one side, I have to do it on the other side. Okay, and that leaves me with x equals the q over that 3 plus the 9z. There it is. Okay, and then last but not least, this one's the same kind of concept. Here's an x, here's another x. Okay, so I'm going to want to use that distributive property, but be careful with this. This is a good one to talk about, so pay attention. Okay, I am going to have to do this trick of factoring it, but before I do that, get rid of any terms that are not going to be part of that factoring. So I notice that, yes, I have an x in it here, and I'll have to do that, but the 4 doesn't have it. Make sure you move that first. So move the term, because if I try to divide by x, I'm dividing through by an x and factoring it out. This does not have an x for me to take from. So I would end up in a bit of a pickle there. Don't get in a pickle, okay? I'm going to move the 4 first. So I'll have r minus 4. And make sure you're only leaving the terms that have that x you're about to factor, because they have an x to give you. Okay, they have an x for me to pull. If you have something that does not have that x that I'm trying to factor, then this whole distributive property concept it won't work for that. So move anything out of the way. Just keep the ones that have the term. Now I can rewrite it in factored form. If I factor the x, I still have the 7. And if I factor this x, I still have that minus s. And on the other side, I have that r minus 4. Okay, and now x is by itself. It's being multiplied by this group. The opposite of that is to divide by that group of stuff. So I'll divide by 7. I get across my 7s. 7 minus s. Okay? And that cancels that. X is now equal to this over that, you know. Like I said, you're not actually fully solving. You're reorganizing and moving things around so that they're solved for a specific variable. So now that we're total pros at that, we can see kind of how that happens in formulas. So we're going to focus here a little bit on formulas. Look at number 11. On number 11, this is a formula that you've seen many times, right? So we've seen this is area of a triangle, or at least I hope it looks familiar. The area of a triangle formula says the area of a triangle is always 1/2 the product of the base times the height. Well, we want to solve that for b, not solve it for any specific number. We don't have values to plug in. We just want to reorganize this very famous and comfortable formula so that instead of it being a equals, it's b equals. That's it, right? So I'm going to take that a equals. We know it's 1/2 the base times the height. And I want to get b alone, okay? So I don't know about you. It doesn't really matter which one to start with, but sometimes I say mathematically it doesn't matter, but realistically it does. I want to get rid of fractions. As much as I love fractions, if I can get rid of one, that's probably where I can start, or at least I'll do it as quickly as I can. So I would love to get rid of that 1/2. I know that the opposite is to multiply by the reciprocal, which in this case is 2/1, or just 2 in other words. So if I multiply both sides by 2, that is the inverse or the opposite of the 1/2. Those 2's will cancel. So I have now 2 times the area equals base times height. And it's already starting to feel better. And then the other option, of course, is getting b alone. They multiplied by height. The opposite is to divide by the height. So you probably never thought about it. Maybe you did. But the base length of any triangle is always equal to the area times 2 divided by the height. right? Just a different perspective, looking at exactly the same relationship from a different and new point of view. We've always had it as A equals. Now we just have a different point of view. We're looking at it through a different window in the house, if you will, right? The base of any triangle is always equal, or the length of the base, right? The area times 2 divided by by the height, sorry, divided by the height. So there you go. And again, we didn't solve anything, we just reorganized it. Try it again on the volume of a cone. Again, this is something that you should be familiar with. You might not remember it, but off the top of your head, but you've used it. You've done cones and surface area and volume. So 1/3 pi r squared times the h, and we want to solve that for the height. We want to get this guy by itself. So first things first, let's get rid of the fraction. Again, the reciprocal of 1/3 is 3/1, or just 3. So multiplying by 3 on both sides will cancel the fraction. Okay, so now I have 3v equals the pi times the r squared times the height. Okay, step 2 here is to get h alone. Well, this is all multiplication, so the height is being multiplied by pi r squared. Well, the opposite of multiplying is dividing, and you can do it all in one step. So if it's all multiplication, then you can just divide the whole thing. You can see right away as you write it, oh yeah, that's all going to cancel because it's all multiplication. So pi over pi, r squared over r squared, it all cancels out. And so h is equal to 3 times the volume divided by pi r squared. And there is the reorganized version of that same formula you've always used. My 2's a little funny. Okay. Next one, Ohm's law. You may not have played with this. You will get to play with it a lot when you get to physics, but not a very complex formula. You have I over VR. So here's I equals V over R, and we're solving for R. So this is one of those that has the R in the denominator, so we do need to fix that. So we got to get it out of there as quickly as possible like we did earlier. So we'll multiply by R on both sides. That way it's out of the denominator. So now we have R times I is equal to V, and now we can get R. Now that it's out of the denominator and it's a regular, whole number up here, then we can isolate it, right? So if it's times I, the opposite of that is to divide by I. So R is equal to V over I. All right, I think y'all are getting the hang of this. I love it. Let's try number 14. I'm gonna go a little bit faster. This is the ideal gas law. You'll also probably mess around with this in chemistry in high school. You've got P times V equals nRT, and we want to solve that for R. And this is just straight multiplication. So it's N times R times T. It's all multiplication, so I can pretty quickly actually get rid of that by just dividing both sides by that NT. And that cancels the T and the N. It leaves R alone. R is equal to PV over NT. Okay. This is one we haven't done a little bit. We've talked a lot about inverse operations, but we haven't done much with exponents, so it's a quick review on what the inverse for that is. On this one, we're solving for z. So I want to get z by itself. This is being added, so don't complicate this. If it's being added and we want to get rid of the whole term, we just do the opposite sign. Okay, if it were multiplying together like this, then I would divide, right? But these are connected through multiplication up here, so I'm dividing. This is not connected through multiplication. There's a big old addition in the middle, and when that's the case, I'm just going to do the opposite sign. Okay, so I'll do that on both sides. That cancels that entire term. I now have z squared is equal, and on the other side I have 3 minus that xy. And now I have to remember, well, that's not z by itself though, that's z squared. So what is the inverse or the opposite of squaring? Well, the inverse or the opposite of squaring is taking the square root. And if we do it on one side, we have to do it on the other side, the whole thing, okay? So in order to do it over here, I have to make sure I do the whole side over there. And then the square root and the square power, they cancel. That's how I eliminate the exponent. And that leaves me with z equals, and so it's going to equal the square root of 3 minus xy. And again, we're not solving, we're just reorganizing. All right, flip it over. Let's talk about number 16. On number 16, the amount, A, of money in an account after simple interest has been earned is given by that equation, A equals P plus PRT, where P is the principal, R is the annual interest, and T is time. So we want to take this formula, solve it for R. So let's do that. So we've got, if we solve this for R, I just want to isolate that. So I'm going to do the opposite sign of this guy that's being added. So A minus P is equal to PRT. And then I'm going to divide both sides so that R stays. This is all multiplication. So I'm going to divide by the P and the T. That cancels both of them in one step. You could separate it out, but why more work, right? And so now I've got A minus P is equal to A minus P over PT is equal to R. So that would be the reorganized version of the same relationship. That would be part A. Part B says the amount of money in an account after interest has been earned is $1,080. The principal is 1,000 and the time is 2 years. So what was the annual interest rate? So they're basically asking me, what is R here, right? What does R equal? And here's where this gets fun, right? I could go back to this, but if I go back to this and I plug in those values, then I have to solve for R. I would have to do all of these steps again, right? Or I could use this new improved version that is already solved for the R that I want. And that's kind of the cool part about this, right? So I'm going to use this one up here that's already solved for the variable I want, and I'm just going to plug my values in. So R equals A, which is the amount of money in the account, that's $1,080, minus P, which is the principal, well, they just told me the principal was $1,000, over the principal, 1,000, times the time, which in this case was 2 years. So remember, this is our A, this is our principal, this is our time, and I'm going to plug them into the one that's already solved. That way I don't have to reinvent this wheel every single time. All I have to do is solve this. Well, 1,080 minus 1,000 is just 80, and then 1,000 times 2 is 2,000. And I can see right away that I can reduce this by 10 and make it 8 over 200. 8 over 200 reduces again to 4 over 100, which I know is 4%. So that's one quick way to find it as a percentage. There's the interest rate right there. Okay, and let's finish this last one out. Letter C, solve the formula for P. So I'm going to go back to this original one. We're just practicing this skill one more time, and we're solving it for P. Well, P is one of those that's in 2 different locations. This is the kind that we're going to use that factoring. I'm going to pull it out, and I'm going to factor it. Well, P divided by P still leaves me a 1, so don't forget about the 1 there, plus, or you can think of this as a 1P. But either way, when the whole thing goes out, you got to hold that spot with a 1. And then here, when I pull the P out in front of the parentheses, I still have the R and the T. Okay? That way, if I distribute this back in, P times 1 is P, and P times RT is that. And now that I have it as multiplication, I will just divide on both sides. And that'll get P alone. So the new version of this is A, because that cancels. So that leaves P alone. So P equals A divided by that 1 plus the RT. There it is. Okay, and we're going to stop here. You don't have to worry about 17 and 18. We're going to do those, but we're going to do those in class tomorrow. So you can stop here. You're done with your notes and your homework tonight. And tomorrow we'll finish these together in class and we'll practice this. And we've got actually a couple of days to practice this and make sure we feel really comfortable. We'll be working on this both on tomorrow and the next day. Have a great night.